It's almost like. Right, guys, we gotta try. There's a lot of people. We gotta try to be quiet. You can come and stand on this side. Jake, don't come in late and annoy people. We might be out, but it's going to be up here if you could see Noah. I'm sorry. I didn't realize there'd be this many people.
Why don't we go to the
Why don't we just do that?
lecture hall?
Because we're here right now. By the time we go to the lecture halls, we'd be late. We'll do. That's a good idea for next time. So.
Where'd you get that? I answered the first one.
I'll give you a couple more minutes to finish the first one. If you're stuck, try to see, can you get like some points at least somewhere? And not really designed for you to get 100%. No, if you can't see, you could come up here. Okay. Stuck in anything?
Yeah.
Good. Did you get them all the time we're standing there? Anyone not signed yet? I got you. No. Who in the back? Ben? I can't. Oh, damn. All right. Anyone else? KB, right? Yeah, I got him. All right. Anyone for her? The total. What's the first thing? What's the total utility from purchasing to Oliver?
24.
24. You just add 10 and 8. The marginal 10, 8 is 18 plus 6 is 24. So it's 24 cars. All right. Teresa's weekly income is 11. The price of a bagel is $2. And the toy cars are $1. Now, whenever you see this maximized utility, somewhere that marginal utility of X over the price of X equals the marginal utility of Y over the price of Y. So they gave me the marginal utility of bagels, but now I gotta put it over the price. So 8 divided by 2 is 4, 7 divided by 2 is 3.5, 6 divided by 2 is 3, 2.5, 2. Okay, now I'm not doing it here only because everything divided by 1 is the same number. But you know, it really should be like 10 divided by 1 is 10 and so forth. Now I want them to equal. So 4 equals 4. So if I look here, she buys 1 bagel times $2, she spends $2. She buys 4 toy cars. She only spends $6. They say spend all 11. So I know that isn't right. So I go to the next time. I know 3.5 can't be right. Those are all even numbers. So I go to 3. So that's 3 bagels. And the marginal utility over price is 3 here, 5 cars. 5 times 1 is 5. 3 times 2 for the price of the bagels is 6. I spent $11. So it's going to be 3 bagels and 5 cars. Okay. Go. Ask if you have, because these come up a lot.
So like, what do you use like the formula for?
Two, you want them to equal to maximize the utility. So this is the marginal utility. 4 equals that. So I'm trying to get them to equal on each side.
So would that be explained here, like?
I think if you showed the math, yes. Yes. Really explaining it is showing the calculation. And then I think if you would, I got the exact, because I wrote down what College Board exactly, the perfect answer for them. The marginal utility, so if you show it, you're explaining that the marginal utility of bagels equals the marginal utility.
So we just write down the formula.
Yes. Okay. All right. Any other question on that one? All right. Assume that the price of wheat and input for the production of bagels increases. So if that is the graph, if the price of wheat, what would shift?
Supply.
Okay, so what are they asking?
If demand increases, so it would be not change, because it would be quantity.
Right, so demand does not change because it's a shift of supply. Okay? All right, income elasticity, and I'm just going to put the formula up here, even though you don't need it, just as a reminder. Income elasticity, quantity demanded is always up top. So the quantity demanded of the change, percent change in quantity demanded over percent change in income. And in the problem, what is it, negative?
Yeah.
A negative number is what? Anyone remember? It's an inferior good. Okay, now, does anyone remember what an inferior good actually is?
Like a luxury.
Yeah, but no, you
Oh wait, that's
yeah,
Income down, demand up.
income down, demand up, or income up, demand down. A normal good is going the same way. All right. Anyone? The last one. Anyone feel they have it?
So 8.
So let me get the formula here. Cross price. Do you remember the formula?
Yeah.
Percentage change of quantity demanded a day over percent. Sorry, percentage change of price of bid. So what's the percentage change of price? How much? 10% of what? Which product?
Of the cars.
So cars, did it increase or decrease, Pat?
It increased.
So that's gonna be 10% on the bottom. And
And then it's 5 above that,
what changed by?
5% fewer toy cars.
We don't want cars, we want the other product. We want blocks.
4.
So it's 4.
Yeah.
So it's gonna be -4/10. All right, remember, it's percentage change of A over the percentage change of B, Evan.
The negative be on the top.
Yeah, it doesn't matter which one.
Why is it -10?
No, he said that, it's -4. I just meant this could be a negative number. All right? Any question on that?
Wait, so it's 0.4, but that means percentage, so it'd be -40%.
It's, yeah. Okay, anyone else? Go.
You said a normal good is,
Demand and income going in the same direction.
okay.
Now, a negative number for cross price is what? Anyone remember? Negative is complement, positive is a substitute. Okay? All right, let's try to do the second one. Give you like 5 minutes on the second one. Second one easier. Yeah.
It's
Okay. All right. Yeah.
Are you doing the same question from the morning or?
Yes.
Something different?
Same exact.
Okay, so. The morning and the night for Thursdays are gonna be like the same? time?
Yeah. Uh,
Because it's not. Oh, yeah.
I'll give you a couple more minutes. Yes,
A is asking for 2 separate PPCs, right?
I think you could put them both on one graph.
Yeah?
Yeah.
Could you draw 2 if you wanted for this or no?
I'm not sure. They want their perfect graph is 1.
They're perfect, right?
I'm thinking if you did 2, you'd probably get away with it.
Okay.
I'm thinking. All right. Okay, if you're reading this, I think one of the things to underline is constant opportunity cost. If the opportunity cost is constant, what does that tell you about the production possibilities curve? Yeah, it's going to be a straight line because resources are easily adaptable. Okay, if it was increasing or they didn't say anything, then it's going to be bowed out. All right, so there is, right, you got helmets for Atlantis, you've got for Xanadu. All right, that gets you a point. Keaton, do you remember the shifters of the production possibilities curve? All right, yes, that is. Yeah.
Quantity or quality or resources and technology.
Quantity, quality of resources, which capital goods would be, or technology. If there's a dot inside the curve, what does that represent? Unemployment, inefficiency, that's kind of a recession. Outside the curve, with present day resources. Okay, good job. All right, so the second thing, calculate the opportunity cost of one helmet. Quinn, is this an input or an output question? It's an output, so it'd be other over. So if I'm looking for the opportunity cost for Atlantis for one helmet, it's the other, which would be baseballs, 200 over 100 or 2. Now, you have to do the 200 over 100 equals 2 because they want to see the work, but that's that. Any questions on that one? This is what they say. So they want 1. I do think they would take 2, but I would try to do 1. See. Take a deep breath, Charlie. Yes.
What did we say for B, just
You take the other,
so 400.
the other 200, because you're doing Atlantis.
Yeah.
200 over 100.
Why would you do the 200?
Because it's Atlantis, they make baseballs and helmets. 200 baseballs, 100 helmets.
So the one that does more first?
Because they're asking you for the opportunity cost of helmets.
Oh.
So it's other over.
Gotcha.
Okay. No problem. That's why you're here. I mean, we're here to review and remember. Which country has the absolute advantage in baseball? Who's got the absolute advantage in baseballs? KB? All right, it's Xanadu because 400 to 200. Can you have the absolute advantage in both? Can you have the comparative advantage in both? All right. What's the next question?
Who has the comparative advantage in baseballs?
In baseballs? So,
Yeah.
so who has?
One of them says Atlantis.
Okay. No, one's absolute, one's right. So the comparative for baseballs is the other 100 over 400, which is a quarter, or 100 over 200, it's a half, quarter smaller, so it's Xanadu. Okay. Now, anyone feel they have E? Jonathan, do you want to explain E? Guys,
Yeah.
go.
What you did is you kind of looked at the opportunity of making one helmet. So for Atlas, that is one helmet is equivalent to 2 baseballs, and for Xanadu, that one helmet is equal to 4 baseballs. So you want any number that's in between 2 and 4. That is, and 3 in between 2 and 4. That
Okay.
should be a fair value.
Does that make sense? Does everyone, because they ask that a lot. Is everyone good? Okay, I said 3:10, it's 3:12, so I will let you be on your way. Thank you for coming.
Thank you for having us.
Oh, yeah.
Jay, for you guys, for practice, is it any harder to get from the lecture hall to practice than here? All right. Yeah. Like if
I didn't need to draw this, I didn't need to draw that, not really.
But that, if you visualize that better, that's fine.
Okay.
So it's because, who had it in baseball? I mean, in helmets,
I do.
Atlantis, right?
Yeah, because they're giving up
Right.
less.
So if Atlantis trades, they're gonna get 3 baseballs, they usually get 2.
Okay.
And they usually give up 4 baseballs and they're only giving up 3. So it's in between a half and quarter, okay?
Yeah.